On the three islands in the northern coast of Queensland, there is a considerable bird migration between these islands, and over the time researchers have observed a trend which is shown in this table over here. What does this table really mean? Well, it means that of all the birds that are currently in power, 75% of them will stay in power. 15% of them will fly to Manu, and 10% of these birds will emigrate or migrate to chalk. So all of these percentages, 75, 15 and 10, add up to 100. And now we can use this information to put it into a transition matrix. But instead of percentages, we'll use proportion, which add up to 1. So in our first row, we'll show the transition from this year to next year of birds migrating from Pau to Manu and then to chalk. And in the next row, we'll show the birds migrating from Manu to Pau and then staying in Manu, 60%, which is 0.6, and migrating to chalk. And similarly, we do the same thing for the birds in chalk that will migrate to Pau, and the birds from chalk migrating to Manu, and the birds from chalk which will be staying in chalk. And can you see that 75% of the birds in power still stay in power, 60% of the birds in Manu still stay in Manu, and 65% of the birds in chalk still stay in chalk next year. And if I multiply these two transition matrices together, I will know what the transition is, or the migration pattern of the birds the next 2 years. And so in 2 years' time, you can see that 60.8% of birds will still stay in Pau, and 43% will still stay in Manu, 47.8% will still stay in chalk. And since 47.8 will still stay in chalk, we know that 27.3% will emigrate to Manu, and 20% will emigrate to Pau. And now in 2017 we have 26% lived in Padua, 39 lived in Manu, and 35 lived in chalk. And this is given to us as the initial state so that we can find the expected population on each island at different times. This information can be used to write the steady state matrix. And now that we are given the initial state, steady state matrix, we can multiply this matrix by the transition matrix to find what the expected population on each island will be. And for instance, if we wanted to find out what the expected population will be in 2018, which will be next year, then we will multiply the original steady state matrix by our transitional matrix. Using calculator, we multiply these two matrices to get, so we can say that 32.6% live on Pau, 34.3% live on Manu, and 33.2% live on chalk. and this happens in 2018, 1 year after. And so for 2019, we would do S2, and we would multiply this matrix by t squared. And if we wanted to look for the population in 2020, that would mean we would have to look for the steady state 3 years after, and this is our calculation, and so on. Now, to determine the steady state, we need to find t to the power n. And as we increase the power of our transition matrix from t to, say, for instance, t14, or even possibly t to the n, we'll find that where n, for instance, could be 100, but we don't need to go as far as that. We'll try t to the 14. And now you'll notice that our rows start to become identical. Each row is identical. And this suggests that high powers of transition matrix converge, and each row could be used to find a steady state. And at steady state, we note that 41.2% of the bird's population live in power, and 29.9% of the bird's population live in Manu. 28.9% of the bird's population live in chalk. But you can see that there is still movement between the islands, because even though 41.2 birds population live in Papua, 29.8% still go to Manu and 28.8% still go to chalk, and so on.